So this video is going to be on the amines topic for the Unit 4 specification, and I'm going to start with understanding amines. So an amine is basically just an ammonia molecule where its hydrogens are replaced with other functional groups. And we can get different degrees of amines depending on the hydrogen atoms. So if one hydrogen atom is replaced, it's a primary amine. If a second hydrogen atom is also replaced, it's a secondary. If a third hydrogen is replaced, it's tertiary. So, to name, there's two ways of naming. We can either add the suffix amine or the prefix amino. This is purely due to preference, and you can use either of these, but the suffix option is more common, but doesn't mean you have to use it. So, an aromatic amine is named phenylamine, and if there's a degree that's greater than 1, you'll have to say di, or for tertiary, tri. And if the functional groups are different, you have to name these alphabetically. So I've kind of put these rules all into one. Excuse me. So for example, in dimethylphenylamine, this would be a tertiary amine. As you can see, I've got the di because obviously there's two methyls. Then I've got the phenyl, which is after the dimethyl. Alphabetically, P is after M. And I've reiterated that here where I've wrote there's two methyl groups and a benzene. And in this case, I've used the suffix amine because 1, it sounds nicer, and 2, I don't know, it's just more common, so I like to use it more. We can also get quaternary amines, and these are known as quaternary ammonium salts. Right, you know that you can get NH3. If you add a hydrogen, you can get NH4+, and that's an ammonium salt, because it will normally be with something like that. So, similarly, we can get a quaternary ammonium salt, and these are used as cationic surfactants, which are used in fabric softeners. Now this is quite confusing. You don't need to know about surfactants, but you do need to mention that quaternary ammonium salts are used as cationic surfactants in fabric softeners. So just to understand what a cationic surfactant is, a surfactant is a long chain which is partly soluble and partly insoluble, and they normally look like this, and that's a skeleton formula, and then this part will be the soluble part. And it's cationic because it'll be positive. So that's basically what a cationic surfactant is. If you didn't understand that, don't worry about it. You just need to remember what to say, and that's quaternary ammonium salts are used as cationic surfactants in fabric softeners. Okay, so finally we need to know about the base properties of the amines. So we know that ammonia is a widely used base. You've probably done it in your MPER/ISA, and you've most certainly done questions on it before. So because amines are derived from ammonia, it's logical then to think that we need to know the base properties for amines. And we do. So aromatic are the weakest type of amine bases. Primary is a stronger base than that. Secondary is an even stronger base, with tertiary being the strongest. I've done the two extremes on a table here. So a phenylamine, which is an aromatic amine, is a weak type of base. The explanation is the delocalized ring of the benzene withdraws electron density from the lone pair on the nitrogen atom, decreasing its ability to accept a proton. You would literally have to say every word in that, but in particular you'd have to mention the delocalized ring, the withdrawing of the electron density from the lone pair on the nitrogen atom, all that would have needed to be specified. Ooh. And then you would need to specify that this decreases its ability to accept a proton. So as you can see, pretty much everything. Then on the other end of the spectrum, we've got a tertiary amine, which is a strong type of base. And this is because you may know, you may not know, you should know, that alkyl groups are electron releasing. This means that as alkyl groups are attached to the amine, they push electron density towards the lone pair on the nitrogen atom, increasing its ability to accept a proton. So it's the inverse of the phenylamine. So again, the key points here would be the alkyl groups are electron releasing. This means that they push electron density towards the lone pair. I guess that's reiterating. But you'd have to say the lone pair on the nitrogen atom, because you need to make clear where it is, and this increases its ability to accept a proton. That's kind of a so what. Putting this also into practice, it could ask you, well, you've got this. And it would say, what's the base properties of this? And you would say that this would be a weak base. The reason for this is the halogen here is electron withdrawing, just like the aromatic, the phenyl. So then this has the exact same effect where electron density from the lone pair here would be withdrawn to there, therefore reducing the ability for this lovely hydrogen to be attracted to this because it's not as negative. Okay, so that's all you really need to know about the amines in terms of understanding them. In my next video I'll explain to you what an amide is. That's just going to be a very short video, possibly even under a minute. And then I'll go on to the reactions of amines, which once you get your head around it, it's quite simple.